Imagine a planet where continents are not fixed, but in constant motion, slowly tearing apart and reforming like puzzle pieces in a cosmic game. That's Earth, our home, where a hidden geological heartbeat is currently splitting Africa in two and birthing a new ocean. But here's where it gets controversial. Is this process a natural inevitability, or a ticking clock for humanity to prepare for seismic upheaval? Let's dive into the science behind this dramatic transformation. Deep within Earth's mantle, a layer of semi-molten rock, heat pulses like a colossal heartbeat. These rhythmic surges, known as mantle upwellings, are the unseen architects of continents and oceans. They fuel volcanoes, crack landmasses, and even sculpt new seabeds. In East Africa's Afar Depression, this drama is playing out in real time. This region is a geologic hotspot where three tectonic plates, the main Ethiopian rift, the Red Sea rift, and the Gulf of Aden rift, grapple like tectonic wrestlers. Scientists have long suspected a massive mantle plume operating beneath this chaos. But its true shape and behavior remained a mystery. Until now. A groundbreaking study by the University of Southampton has unveiled the first detailed portrait of this subterranean force. Researchers collected lava samples from over 130 young volcanoes, analyzing their chemical fingerprints to decode the mantle's secrets. What they discovered defied expectations. The upwelling isn't a single uniform stream, but a chaotic mosaic of plumes and hot material, more like a patchwork quilt than a unified current. The mantle beneath Afar pulses with distinct chemical signatures, explains lead author Emma Watts. These molten pulses are channeled by the stretching plates above, accelerating the continent's breakup. And this is the part most people miss. The mantle's heartbeat isn't steady. It adapts to the tectonic dance above. In the Red Sea rift, where the crust is rapidly pulling apart, the upwelling surges faster and more forcefully. In slower zones, it spreads out like ink in water. Co-author Tom Gernon likens this variability to a cardiovascular rhythm. The chemical striping suggests the plume pulses like a heartbeat, faster when the plate is thin, slower when it's thick. But how does this connect to the surface? The plume is eroding Earth's rigid outer shell, the lithosphere, thinning it to just 15 kilometers in places. Combined with tectonic stretching, this creates a perfect storm for volcanic eruptions and earthquakes. Ethiopia's landscapes are already scarred by lava flows and seismic swarms, hinting at the ocean basin forming beneath them. Eventually, seawater will flood in, splitting the Horn of Africa from the mainland, a process mirroring how the Atlantic Ocean tore away from Europe and North America. This isn't just a regional story. Mantle upwellings like the one in Afar could explain Earth's most catastrophic volcanic events, from the Giant's Causeway in Northern Ireland to ancient eruptions that may have triggered mass extinctions. Understanding their rhythm could help predict future geological upheavals and their climate impacts. As co-author Derek Keir notes, deep mantle processes are intricately linked to surface phenomena like volcanism and earthquakes. Without this connection, we're missing half the puzzle. So what's next? Researchers plan to map how mantle flow directs volcanic activity in thin plates and how fast these processes occur. Collaboration is key, Watts emphasizes. Like solving a puzzle without all the pieces, we need diverse expertise to see the full picture. For now, scientists can hear the pulse of this mantle heartbeat beneath Ethiopia, a rhythmic signal of a planet in motion. But here's a question for you. If Earth's deep forces are shaping our future, are we ready to listen? Share your thoughts in the comments. Do you think this geological shift will redefine human history, or is it a distant threat we can ignore for now?